Modern chemistry thrives in pristine environments. We take for granted the high-tech ventilation and specialized glass flasks, allowing us to manipulate matter with total precision. In 750 CE, this reality didn't exist. Chemistry was not yet a science. Scholars relied on inherited wisdom, treating handwritten manuscripts as the final word. They had a deep theoretical grasp, visible in intricate diagrams, but lacked a system to test these abstract ideas physically. These ideas converged in Tus, Khorasan. Within these ancient mud brick walls, merchants and philosophers traded theories and raw materials, yet the two rarely met practically. The ancient world was rich in both materials and philosophy, but it remained in a scientific vacuum. It lacked a bridge, a rigorous method to prove which theories were true and which were merely myths. Young Jabir ibn Hayyan grew up at the center of this world. In his father's apothecary shop, he spent his days weighing herbs and grinding rare minerals, gaining a first-hand understanding of the properties of the natural world. That life ended abruptly. For supporting a political rebellion, Jabir's father was arrested and dragged into the night to face execution. At 12 years old, Jabir's world collapsed. His family was stripped of their wealth and status, forced to flee their home with nothing but the clothes on their backs. They were cast into the deep isolation of the Arabian Peninsula. This landscape defines the scale of their exile, endless orange dunes stretching to the horizon, a place where a refugee had to be resilient just to survive. This trauma erased Jabir's past, but it also removed the constraints of his old life. He was a blank slate, and the poverty of the desert only sharpened his resolve to find a more stable truth in the world around him. Years in exile became a period of intense, disciplined study. Jabir devoted himself to mastering mathematics, philosophy, and medicine, seeking a logic that political storms couldn't take away. His search eventually led him to the scholar Jafar al-Sadiq. This encounter provided Jabir with a specific intellectual framework he had been missing his entire life. Al-Sadiq issued a challenge that broke from centuries of tradition. Do not simply trust what is written. Instead, you must observe with your own eyes, manipulate materials with your own hands, and test your conclusions with the heat of a flame. This shift toward empirical testing was the missing link. It allowed Jabir to take the practical skills he had learned in the apothecary and apply them to a higher, more rigorous philosophy. Jabir moved his childhood knowledge into a more aggressive realm. He began constructing mechanical rigs designed to force matter through specific physical changes, documenting every result. One of his most influential designs was the copper alembic, a tool that allowed for distillation. This process separated substances by boiling a liquid and then cooling the vapor in interconnected chambers to collect a purified result. He perfected crystallization, a method used to purify chemical compounds. By dissolving materials and allowing them to reform, he produced these sharp, needle-like crystals, ensuring he was working with the purest possible matter. He continued with sublimation, finding ways to turn solid materials directly into gas, bypassing the liquid state entirely to reach even higher levels of chemical purity. Geber did something the ancient Greeks never did. He wrote down his experiments with enough technical detail that others could repeat them. By focusing strictly on measurable, repeatable results, he transformed the act of trial and error into a formal scientific discipline. This new, disciplined approach led to the discovery of substances that would change history. In this bottle is one of Jabir's primary contributions, nitric acid, a powerful compound capable of dissolving metals. These acids became foundational to human progress. Centuries after Jabir's death, they would power global industries, from the manufacturing of fertilizers to the production of high-strength alloys. Jabir's extensive Arabic manuscripts were titled Alchemy. When these texts reached Europe, they were translated and studied so widely that they gave us the modern name of the science itself, chemistry. The tools of modern science were forged in the makeshift workspaces of a refugee. Jabir ibn Hayyan's life proves that the human drive for truth is resilient enough to survive tragedy and build the foundations of our modern world.